still lots of people don't know that we're here. We get a lot of schools, a lot of homeschoolers, a lot of scout troops, a lot of families, whatever. We live off donations. There is a donation box next to the back door. If you like what we do here and you feel that is of value to the population, then please leave a small donation there so we can maintain the equipment and keep it going. As you can see, we have t-shirts. We also have mugs, drinking mugs. We have the books and small telescopes for donations as well. And so you don't have to go home empty-handed. You give them a small donation. Any questions about what we do and why we do it and how we do it? Mike Hotka is our speaker tonight. Mike is working at Ball Aerospace as a senior software development engineer, working on software for spacecraft and all kinds of fancy stuff. He's going to talk to us tonight about Neptune, discovery of Neptune, how they figured out where it was, where it had to be, why it had to be there. And he is kind of a space cadet himself. Solar system ambassador for JPL. He's done public speaking many times, and I don't know what else. He has so many titles in the writer today without any papers.
Hopefully you'll enjoy my talk. That's all I care.
And he'll talk for about 45 minutes. He'll encourage questions during the talk.
Absolutely.
So feel free to talk and interrupt him about 45, 50 minutes, and hopefully the clouds cooperate and move away a little bit so that we can see something tonight with the telescope. So with that, I'll turn it over to Mike Hotka.
I want to thank everybody for coming out, supporting the Thompson Observatory, and listening to me ramble about the stuff I love to talk about. So, a little bit more about myself. I build my own telescopes. This is an 8-inch telescope that I built. During the summer, on Friday nights up at Rocky Mountain National Park, they have an astronomy program in Upper Beaver Meadows. And this is what I was supporting this night. You got Long's Peak in the back. This is a telescope my dad and I built when I was in high school. I used it for 40 years, retired it last year. You can see the fancy counterweight there in the back, which is basically a sea plant. And I replaced it with this new scope that I built. It's computerized, go-to, it's marvelous. I love it. As Mike has said, I work with Ball Aerospace, I work with databases, I work with all the databases to all the different spacecraft we build at Ball, so I get to touch almost everything.
Who are you in that picture?
I am this guy right here, and they gave me grief because I pointed the wrong way, but I thought we would trade the spacecraft. This is the team I work with here, and this is me right here. This is called a Class 10,000 clean room, so you have to get all garbed up because, believe it or not, we all have this cloud of skin particles all around us right now. And if we didn't put on these special outfits, the spacecraft could get contaminated. And this was short of launch. This was like 2 months before launch. They took everybody in here, got our picture taken with it.
Which spacecraft, Michael?
This is Digital Globe's spacecraft. You'll see pictures of this on Google Earth.
So is this Worldview?
This is Digital Globe Worldview 2, it's called.
Okay.
So Digital Globe is a company at Longmont. All right. So my talk's about the discovery of Neptune. So this is the known solar system to mankind when they first started looking up into the sky. Planet is Greek and it means wanderer. These stars wandered amongst the fixed stars in the sky, and people could see that for a long time. Well, this all changed about 10 p.m. on March 13th of 1781, and you'll see why in a second. How many people have heard of Johannes Kepler? Wow! Hey, you didn't know you were going to have a quiz tonight, but I'm going to show you people that you might not have heard of by the time we get down to the players of this talk. Well, Johannes Kepler, with respect to this talk, was shortly after Copernicus kind of put the sun at the center of the solar system, and before that, if you recall, everybody had the Earth at the center of the solar system and the planets orbited the Earth. Well, Johannes Kepler looked at a lot of observations by a man named Tycho Brahe, and he took meticulous positions of the planets, including the planet Mars. And Kepler, what he did was he was trying to explain some of the weirdness of planetary motion. something we call retrograde, they call epicycles. And basically the planet appeared to go backwards in the sky for a short time before it went forward again. And so Kepler studied Tycho Brahe's observations and came up with 3 laws of planetary motion. And this was kind of revolutionary because people at the time thought the planets circled the sun in circular orbits at a constant speed. And what Kepler found by his first law, hey, you got the next, you guys heard the next time? I'm not going to do this. I used one of these at another talk, and I did that all night. So I'm going to use a separate one that's different. He said that the planets orbit the sun in something called ellipses, and the sun is at one foci, which is a term of an ellipse. So they're not circular, but they're nearly circular. His second law said that the planet sweeps out equal areas in its orbit in equal times. So say this arrow is 1 month. Well, this arrow is 1 month. So this area is equal to this area, and basically it says that when the planet's closer to the sun, it moves faster in its orbit than when it's farthest from the sun. And people thought it was constant speed. But his second law said, no, it's not. And the third law basically relates the distance the planet is from the sun with how long it takes to go around the sun. Now, you've got a prelude. How many people have heard of Isaac Newton? All right. With respect to this talk, Isaac Newton is the one that sat under the apple tree. The apple hit him in the head. He said, I've discovered gravity. Well, he really didn't discover gravity, but he was the first one to characterize gravity. And one summer when England was having one of its bad plagues, anybody that was healthy was allowed to go to the countryside. So he went to the countryside and he was asking himself the question, is the gravity that made that apple fall from the tree the same gravity that keeps the moon orbiting the earth and the planets orbiting the sun? This is the question that he had. So one summer, during that time where he left England, he invented calculus to prove that. How many people have taken calculus? Did you like it? Yeah. But he invented it just to prove that it was indeed the same gravity that made that apple fall that kept the planets behaving the way they did. And here is his general gravitational equation that he came up with. How many people have heard of Edmund Halley? Halley's Comet comes around every 76 years. See, I'm almost preaching to the choir here with all the volunteers in the room. But with respect to this talk, Halley was the first one to really say, I think this comet was the same one that's in records that was here 76 years before this, and what other people saw 76 years before that. But he didn't have any way to prove it. So he was talking with Newton one day and said, I wish there was a way to prove this. Well, Newton opens a drawer of his desk and takes out calculus that he had invented 20 years before. He just used it to prove his gravity and put it away. And Halley said, you've got to publish this because this is really good stuff. So he did. How many people know what this is a picture of? So what are Jupiter's moons? What is it? You know? 2 letters. Begins with an I, ends in an O. Io, absolutely. This is Jupiter's moon, Io. Okay? And this was taken with a spacecraft called Voyager that flew past the Jovian system in the late 70s. And what it shows is it really surprised people because it has this volcano that it took a picture of that was actively spewing lava into the atmosphere. This is 20 miles high above the surface of this moon. It's a lot of energy. Nothing on Earth has that kind of energy. And astronomers and scientists at the time thought the Earth was the only place that had active volcanoes like this. Well, here's pictures and evidence of it happening on another body in the solar system. So what's causing this to happen? On Earth, our volcanoes are because of plate tectonics. 2 plates are pushing on each other. The friction generates a lot of heat. The heat melts the rock. The rock finds a little crack in the crust and comes up and makes lava on the surface. But Io is geologically dead. There is nothing like that going on at Io. So what's the mechanism? Gravity. It's a huge tug of war going on with that little tiny moon between the massive Jupiter and the other 3 large Galilean moons. And what they're doing is they're pulling on this little moon and squishing its crust like a rubber ball. So that squishing of the crust by gravity is causing the heat to make those volcanoes happen. So I just kind of hinted at it. What is the one thing you have to have in order to have gravity?
You need to have other gravity?
No, it begins with M.
Mass.
Mass. The more massive something is, the more gravitational influence it has on the space around it. So this is where I want to run that animation. So if you could swap over. I have my first sleeper in that row.
That's classic.
So it was on the bottom. There we go. And just starting with the little screen down here. There you go. Go back. Hit escape. Bring up the black hole presentation. Down to the bottom toolbar. And hit the little icon over here, full screen. Over here left. Lower left.
Your other left.
Right there. Right there. No, right there. That guy right there. There you go. Perfect. Thank you. I couldn't figure out how to embed this in the presentation. This is another PowerPoint. But what this is a series of actual pictures of stars. And that red plus is the center of our Milky Way galaxy. So these are actual pictures of the heat of stars taken from a spacecraft that looks at heat. And you can see that this is the years, so it's about a 15-year period, a very narrow part of the center of our galaxy. And you can see that the stars are orbiting something. Does anybody know what's at the center of our galaxy? See, it's going to be quiz tonight. You didn't know that.
Black hole.
A black hole. Black hole is a very massive object. The more mass you have, the more gravitational influence on the space around it. Watch this guy coming from the upper left. Just pokes around. Whoa. That's cool. That's what's going on at the center of our galaxy. Well, back in the late 90s. Okay, escape and go back to the other presentation. Isn't that pretty cool?
Yeah.
I like that one. Oh, you look at you can see what I'm going to talk about. But even on a little spacecraft flying through the solar system, it has influences of Earth. Say you're flying it to Mars, so it has influences from Earth, the Sun, and Mars. So space controllers that are controlling a spacecraft have to take into account all those gravitational perturbations, is what they're called, in order to get that spacecraft from here to there.
Now, Ron, I saw in the black hole part, it said 10 light days.
10 light days.
So is that like dog days or like
It's a very good question. Astronomers, when you get away from the solar system, start measuring things in light years. And basically, that's the distance light travels in 1 year. So 10 light days is the distance light would travel in 10 days. So it's a big distance, but not as big as a light year. So it kind of shows you it's a very narrow part of the center of our galaxy. But that's what it means. 10 light days is the distance light would travel in 10 days. Okay?
yeah,
How big would that be compared to like the solar system?
Oh, the solar system is measured in something called astronomical units, and that's the distance from the Earth to the Sun. And I think even to the farthest reaches is only 100 or 200 astronomical units. And that's only 93 million miles. Light travels like, 6 trillion miles a second? About miles per second. Okay, so that's like times 3,600 for an hour, and then, so it's huge.
Hey, Mike.
Yes?
I just heard an interesting thing on that.
Okay.
The first Voyager, I think, is almost now 1 light day after 40 years. That's how long it's taken to travel 1 light day.
So 1 light day. Voyager, that spacecraft, is at the edge of the sun's gravitational field. So that's about 1 light day. And this is 10 times that. So it's huge. It's huge. I can't characterize it and anything other than that. There's nothing that I know of. Okay. Currently, is there a space? Yes.
So the image that you showed us with the stars going around
Yes.
the center of the galaxy, I thought that part of the galaxy, like the core of the galaxy, is actually masked from us. somehow.
It is, absolutely. Very good
So
question.
how do we get those pictures
Very
of
good
the
question.
stars moving?
It's masked from us from the fact that there's a lot of dust and gas between us and the center of the galaxy. So in order to see that, we have to look down at that part of the galaxy in a special wavelength called infrared light. And infrared light comes right through that dust and gas like it wasn't there. So this satellite was called Iris, launched in the early 90s, looked in the infrared. So it's watching the center of our galaxy in the infrared wavelength, and it's seeing the heat from those stars. That's what those pictures were. Not really the stars themselves, but the heat from those stars. So that's how they can see the center of the galaxy. Infrared, it's very visible. Through our telescope upstairs, we don't have a whole prayer because there's too much. Okay. So, is there currently a spacecraft going from Earth to Mars as I speak?
Yes.
What's it called, do you know?
Curiosity?
Curiosity. What is Curiosity?
A rover?
A rover. It's the next generation Mars rover. When's it going to touch down on the Martian surface? Early August. Early August. So stay tuned. But even on a planetary scale, the planets, when they get close to each other, their gravity attracts, nudges them out of their orbits. Very key point in this talk. How many people have heard of William Herschel? He's been coined the grandfather of observational astronomy. He was an amateur astronomer, not a professional astronomer in England. And he was a musician by trade. And at one point, he had the biggest telescope in his backyard, bigger than anything the King of England owned. It had a 4-foot diameter mirror, had a 40-foot focal length, and weighed a ton. He had that in his backyard. Of course, it was dark in those days in England. So William Herschel, on the evening of March 13th, 1781, what he liked to look at was double stars. How he would find double stars is he would just swing his telescope through the heavens looking at whatever he could find. He did. That's what we do as amateurs. Okay? See, mine was said. And about 10 to 11 p.m., he swung his telescope across Uranus. But he didn't know he had found a planet. In his telescope, stars were little pinpoints. This thing looked like a disk. He had thought he had found a comet, because that was what they found in those days. So he reported it to the Royal Astronomical Society of England, which was like the clearinghouse for all kinds of observations. And he said he had observed it at several powers, but one of them was 932 power. Well, everybody at the Royal Observatory thought he was nuts, because they only had 270 power, and they thought they had the best instruments in the world. So he had to pack his telescope up, which I'll show you in a minute, take it to the Royal Observatory, and show them that not only did he have a telescope in these eyepieces, but they were far superior to anything the Royal Observatory had.
How long did it take him just to pack it?
Well, you know, he lived out in the country. He lived in Bode, and when I was there, it took me almost 2 hours to drive about 70 miles an hour from London to Bode. So by horse and carriage, it probably took him 3 or 4 days. So, but his telescope wasn't very big. It wasn't that big monster I just showed you. I'll show it to you in a minute. So people started looking at Herschel's comet, and it didn't behave like a comet, because one thing a comet will have is even when it's far out in space, it'll have a little coma around it. What's the coma? Does anybody know? Ice and dust that have kind of burned off the comet. When it gets close to the sun, the coma gets blown into the tail by the solar wind, but way out, it's always like a little fuzzball. And this wasn't like that. It was very much a disk. Somebody plotted the orbit of this comet and realized it behaved more like a planet than a comet. So As of that time, the solar system grew by one planet. Here's the telescope that he discovered it with, so it would be really easy to put in a horse and buggy. It had about a 6-inch mirror and had a 7-foot focal length, and it was his favorite telescope to use. So you're asking yourself, what does this have to do with anything with the discovery of Neptune? I'll tell you, it has everything to do with it. About 1821, so Neptune was discovered, or Uranus was discovered in, what, 1731? 1781. So about 40 years later, a man, a French astronomer by the name of Alexis Bouvard, made some tables of Uranus' position. And he was trying to predict in the sky where it was going to be, because that's what they did in those days. And it was basically used in navigation, ship navigation, to try to figure out what longitude the ship was at. Because this is still about 60 years before a chronometer was invented, which would give them absolute time, and they would know beyond a question of a doubt what latitude or longitude they were. But before then, they used these planetary tables. Well, in 1821, this French astronomer made these tables, and no matter how he worked the numbers, after a year or so, Uranus wasn't where it was supposed to be. It was way off. It was way off more than just by error. So people speculated, well, there's got to be things going on out there. Is it being hit by comets, knocking it off course? Well, if that was the case, then you'd see more comets around the Earth, and they weren't seeing that, so that was not the way to go. People thought there was a special ether out there, that's what they called it, some kind of an atmosphere that Uranus was going through that was slowing it down. Well, back even in the Greek philosopher times, they had kicked out the ether idea at Earth, so if it didn't exist here, people said it didn't exist there. So they really didn't know what was going on with the errors in Uranus. How many people have heard of George Airy? All righty, we're down to the hardcore. This guy was the director of the Chamberlain Observatory, which is prominent in this story a little bit later on. But he was in 1835 appointed Astronomer Royal of the Royal Observatory. So this guy is short of royalty without, well, he's like royalty without being a knight. So he was the top dog of the Royal Observatory. But like I said before, the Royal Observatory's job was to make tables for the British Navy and the British Merchant Marine, so they could try to figure out what longitude they were wherever they sailed. So they weren't in the habit of discovering new stuff. Their job was to study the known solar system and chart it. Well, one thing that George Airy thought was that there was always something wrong with Alexis Bouvard's calculations, and that's why there was something wrong with Uranus's orbit. And that's what he kind of stuck with right up to the very end, and you'll see that. One of our main players, I won't ask you who this is because I'll tell you who this is. This is one of the main players of the story. He was a math whiz at a very early age, but he was very timid and shy. He was the son of a farmer, so he really lacked social skills. And that will come into play shortly, and you will see that. He went to Cambridge, where George Airy was the director of Cambridge Observatory. He went to Cambridge, graduated with a degree in mathematics. And the references that I used to put this talk together had everything down to the date, which is kind of fascinating. On June 26th of 1839, his life changed forever when he picked up a book that George Airy had written 9 years before and said, there is something wrong at Uranus, but we don't know why. It caught John Adams' fascination, and he was hooked. The other player in here is a Frenchman, Urbain Le Verrier. As compared to John Adams, Le Verrier was a very ambitious and talented French astronomical mathematician. He had already published a lot of papers on planetary perturbations, so he was kind of an expert. And he was looking for something to establish his career. He published already, but he wanted more. So the astronomer royal of the French observatory said, why don't you figure out what's going on at Uranus? So Urbain Verrier was hooked. A little more background. In the late 1700s, a man by the name of Bode put together a mathematical relationship of the solar system. It's called Bode's law. And it happens to be very coincidental of something called a radius of orbit and what actually happens with the planets. And it coincides very nicely with the planets, except something was missing at radius of orbit 28. There was no planet there. So people started looking for planets, and instead of finding one, they found many. These are called minor planets. They speculated at the time that this maybe was a whole planet, somehow got broke up, and these are the pieces that were left over. They are at radius of orbit 28, matching Bode's law prediction very nicely. So everybody thought that this was a good law. So back to John Adams. He's going to be the first person to ever do this. Nobody had ever done this before him. Urbain Verrier was about 9 months behind him in his calculations. But John, he's going to analyze the position of Uranus. Up to this point, there were 21 observations of Uranus and its position in the sky. He's going to analyze that position, predict where it should have been, which would have introduced the error in his calculations. He's going to pinpoint the position of this undiscovered planet. To both John and Urbain, there was no question in their mind that there was another planet beyond Uranus perturbing its orbit. There was none of these comets, none of this ether, it was another planet. So he fixed on that, and he was going to do that nothing more than with a pen, paper, and his intellect. He didn't have calculators, he didn't have a computer, he just had pen and paper. He did the math. This is the math he did. Gnarly equations. He made 21 of these equations. Each equation like this characterized one error in Uranus's orbit of the 21 observations. And then he proceeded to solve these simultaneously. 21 of these. It's gnarly math. Gnarly math. Anyway, he did it also in the summer because once he graduated in mathematics from Cambridge, he worked at the Cambridge Observatory with whatever they were working on. So during the school year, so to speak, he would be working at Cambridge, and he did these calculations in the summertime. By September of 1845, he had characterized Uranus's error. He knew what the correct orbit for Uranus was. With that in hand, he knew the orbital characteristics of this unforeseen planet, this Neptune. And by 1 month later, he had predicted the orbit of Neptune, and he had his first prediction, which was on the Capricorn-Aquarius border, which is on our wall over here. Well, I'll show you later. That one's there. Why don't you focus down here? And he put his planet on this line. What is that line? Does anybody know?
It's orbit.
Orbit of what? She said it. I heard it. It's the ecliptic. It's the imaginary path that the sun traces amongst the constellations in the sky. It's basically where the planets are, too, relatively speaking. So it was a very logical assumption for him to put his prediction on the ecliptic. So with his calculations done, he's going to approach Airy. But remember, George Airy is like royalty. Okay, he's not a knight, but he's almost that important in England. And instead of making an appointment like any normal person would do, he got on his carriage and he drove to London and knocked on his door. The first time he knocked on his door, George Airy was on vacation, for an extended vacation. He wasn't there. He came back again. George Airy was eating dinner and the servants wouldn't let him in. Why he didn't wait for him to finish dinner, I don't know. But he left a note and went back to Cambridge. Well, George Airy read Adams' note, but he was very skeptical of the work. because nobody had ever done this before. It was incomprehensible to the people of that time that somebody could sit down and calculate this. So George Airy asked John Adams for clarification of the radius vector, the distance to Uranus. Okay? John gets this request. He thinks it's a joke. If I know what the problem is, because it's the wrong orbit for Uranus, he's the head of the Royal Observatory. He should know this. So he's testing me. So John ignored the request. When George didn't get a reply back, George ignored John. Now, Urbain Le Verrier's approach, completely different. John Adams made 21 equations and solved them simultaneously. What Urbain Le Verrier did was he took the position of Uranus on January 1st of 1800, and they both used the orbit of Bode's law, okay? So this is Bode's law's orbit, and what Urbain Le Verrier did was he took 40 Neptunes, put them on this orbit 9 degrees apart, and he calculated what would the mass have to be of Neptune in order for it to perturb Uranus on January 1st of 1800. Now, he, in very short order, came up with some planets that had a huge mass, so he threw those out. He came up with some planets that had a negative mass. He threw those out. And he came up very quickly and realized that he found the position of Neptune, wherever it was, and it had a very similar mass to Uranus, which was a logical assumption. So about 9 months after John Adams had his prediction, Urbain Le Verrier had his first prediction. He too calculated that Neptune would be found on the Capricorn Aquarius border. He put it on the ecliptic, very logical assumption. John Adams' prediction, Urbain Le Verrier's prediction. Two completely different, independent mathematical processes, and they came up with the same answer. Same answer. Same answer. Incredible. Again, pen, paper, and lead. That's all they have. I'm shaking. This is cool. I don't know. This is cool. So now the race begins. All this time, Urbain Le Verrier is publishing papers. He publishes the first paper, says, I think there's a planet beyond Uranus. George Airy reads that and says, maybe there's something here. He publishes a second paper. It has the position that Urbain Le Verrier said where Neptune should be. For 9 months, George Airy's been sitting on John Adams' prediction. He realizes that they're almost identical. So again, remember, the Royal Observatory was in charge of observing the known heavens. They didn't have time to go find the rogue planet. So he instructed the Chamberlain Observatory and then director James Chalice to look for this planet in July of 1846. Very important date. James worked with John. He knew John Adams. They worked very closely. Yet he too was not convinced that someone could calculate this planet. So he made a half-hearted attempt to find the planet. And we'll see shortly that he actually did, but he didn't know it. But over in France, Urbain Le Verrier was having the very same problem with the French government. He could not get the French Royal Observatory to look for his planet either. So, Urbain Le Verrier came up with a novel approach. He's going to ask the Berlin Observatory to find it. I found these pictures of the different players, different from what we saw before. Here's George Airy, director of the Royal Observatory, John Adams, James Chalice, Alexis Bouvard, whose 1821 tables started this whole question of what's wrong at Uranus. Francois Arago, who was the astronomer royal of the French Observatory, who told Urbain Le Verrier, go figure out what's going on at Uranus. And then the Germans. Johannes Kepler, he was the director of the Berlin Observatory. Urbain Le Verrier approached him on all days his birthday, so he was in a pretty good mood. And he said, okay, we'll find your planet, no problem. And he instructed Johann Gall and Henri the rest to actually do the observations. Here's a picture of the Berlin Observatory, and here is the actual telescope in a museum in Munich. I'd love to see this telescope someday. That was used to discover Neptune. Now, one advantage that the Berlin Observatory had at this time that other observatories in Europe didn't was they were in the process of making detailed star charts of the heavens. So the two guys ran down to the vaults, looked around, and realized that they, a year before, had just finished detailed star charts of the Capricorn-Aquarius border. They had it there. So, on the night of September 23rd, Gall was at the eyepiece calling out stars, and de Rest was looking at the star chart. Gall would call out a star, and de Rest would say, yep, I see that one on my chart. After a few stars, there was one that Gall called out that wasn't on the chart. But, what do they have at this point? Have they discovered Neptune or not? No. No, why not? What could be wrong?
A star they missed.
A star they missed, absolutely. The charts are wrong. One thing that I didn't mention, but I did sort of, planets are wanderers. If this was not a star, it was a planet, what is it going to do the next night? It's going to move. It's going to move. So they had to wait for the next night. Thank goodness it was clear. And they waited and waited until it got dark enough. They swung the scope over there, and lo and behold, it had moved. They had discovered Neptune. They announced it to the world on October 1st of 1846. Now this is 6 weeks after James Chalice was instructed to find it, and he never did. So the British had the upper hand, but they didn't know it. Here's the star map that was actually used. Annotations there in German. Here's where Verrier said it was supposed to be. Here's where they found it. Again, it shows it right here. It's very close to there, but both men nailed it. They nailed it. I mean, we're talking 360 degrees. They nailed it. It's a stroke of luck that these men even succeeded, even with the methods that they used. Bode's law happened to be coincidental, except when you get to Neptune. It's way off. And they both made that assumption that it would be found, the planet would be found on the Bode's law orbit. It wasn't. The second thing that was the stroke of luck is the planets were closest in 1822. So their gravitational perturbation, their attraction, hence why I set up all this at the beginning so you could understand the influence of gravity, made the greatest influence on Uranus, making it always where it wasn't supposed to be. If this was any other time where the planets were on opposite sides of their orbits, Uranus would have been exactly where Alexis Bouvard said it should have been. There would have been no question. These two mathematicians would have never done their magic. So it was only in this time that this process could have even happened. And again, I'm showing you that here. How many people heard John Herschel? Have we heard of another Herschel? Carolyn, but I meant in tonight's talk. Somebody knows about Carolyn. In tonight's talk. William, are they related? Yeah. Yeah. This is his son. This is his son. His dad was an amateur. John's a professional. He works for the Royal Observatory. He decides that it's time for the world to understand that two men had calculated this position, not one. As soon as he did that, the French are accusing the English of trying to steal their planet. And it was a big war in the papers. This is the part where I need to come look at my notes. So, at this point, James Chalice now reviews his earlier observations. And he made two observations on July 30th and August 4th of that year when he was told to. And he went and on August 12th, he went back and he started comparing stars. And he compared 39 stars of his two-night observation. And they were identical, okay? So he proved his process was sound. He could find Neptune with his process. But he never went back to finish it. History does only one that knows why. If he had made 10 more star observations on the August 12th, the 49th star was Neptune. The 49th star had moved. he would have discovered Neptune if he had just compared 10 more stars that night. So he reports that to George Airy, and now the Royal Astronomical Society wants to know, why didn't we discover it? Why didn't the British discover it? We had everything in hand, but it wasn't discovered. So they made an inquiry, kind of like a congressional hearing we have today. They call the 3 men up, and only John Adams looked like a star. The other 2 kind of passed above it. And all this time, John Herschel is trying to mediate this vicious press attack between the English and the French papers. John Herschel, even himself, admits credit should be given solely to Urbain Le Verrier because he published. And everybody knows he who publishes gets the credit. Immediately, Urbain Le Verrier is getting all kinds of rewards and accolades from his discovery. He even eventually becomes the director of Astronomer Royal of the Paris Observatory. But the Royal Astronomical Society had this gold medal, and they gave one out every year to someone who does great astronomical something or others, whatever that is. They wanted to give it to Urbain Le Verrier, but they wouldn't give it to John Adams. John Herschel said, you can't do that. So that year, they never gave out a gold medal. John Herschel convinces the king to knight Adams for his efforts. Well, John Adams said, remember, he's a humble man, son of a farmer. He thought he was not on the same caliber as Isaac Newton. Isaac Newton was knighted. He was Sir Isaac Newton. And in reality, looking back on it, in my personal opinion, these 2 were giants. He should have taken the knighthood. But the 2 men finally met in June of 1847, about 6 months, 7 months after the discovery. And they met at a party. There was a party set up in their honor. And anybody who was anybody in the astronomical community of Europe was there. Why? They wanted to see how these 2 men were going to react. That's all they were there for. And what they found was these 2 guys walked up to each other, shook hands like they were good friends, and were like brothers for the rest of their professional careers. They worked on a lot of astronomical problems together by correspondence, but it was to everybody's surprise. And John Herschel finally becomes the head of the Royal Astronomical Society, and he gives both men something called special testimonials, which is, I guess in the time, was really good. So, last November, Neptune returned to the scene of the crime, the 1-year anniversary of the discovery. Why did I say 1 year?
1 year for Neptune.
Who what?
1 year for Neptune.
1 year for Neptune. What's the definition of a year?
The time for the run around the sun.
For each planet, a year is different. It's the time it takes that planet to go around the sun. So this is the first Neptune year anniversary of this discovery. You can see Urbain Le Verrier's prediction again, John Adams' prediction, and here's where it was discovered. So the first week in November of last year, it was back to the scene of the crime. This mathematical techniques paved the way for lots of discoveries, because you could use math now to model things, and then you could look in nature or society or whatever you're trying to model and observe the behavior. Well, in the 1990s, planets were being discovered around other stars by watching the behavior of the parent star. And if you had a big planet like Jupiter orbiting that star, the star would move, and you could look at it at a special wavelength and see it move and detect the presence of that planet. But today, we don't do that. We use a spacecraft. Does anybody know what the name of this spacecraft is? I'm sorry? Kepler. Did we hear about a Kepler earlier tonight? It's named after Johannes Kepler. And what this spacecraft is doing, this was built at Ball Aerospace. It's being flown by Colorado University, the last observatory, or last flight control center there on the campus. And it's watching stars pass in front of, or planets pass in front of stars. And when that happens, a little bit of that starlight is blocked. And this telescope is sensitive enough in space to detect when a planet goes in front of a star. And as Mike earlier alluded to, on the afternoon of June 5th, which is a Tuesday, the Little Thompson Observatory is going to be open at 5, you told me once, right? That afternoon. Because first contact is when the planet first touches the edge of the sun, Venus, is at 6:10. So by the time the sun sets in the western sky, Venus will have progressed about halfway across the sun. Now, to some people, I hear it's boring. To me, I can't wait. This happens 2 times every 122 years. The first time was 8 years ago. This is the last time in our lifetime and your lifetime to see this. Now, your kids will see it again, but not you. Okay? 122 years from now, it'll happen again. Okay? So in conclusion, John Herschel, on this evening, was sweeping his telescope through the sky like his dad did. He came within a half a degree of Neptune. Now, if his telescope had hit Neptune, like his dad, he would have seen the disk of a planet, he would have discovered it just like his dad. What are the odds that his dad discovers the 7th planet from the sun, sweeping his telescope through the sky, and his son discovers the 8th planet from the sun by the very same technique? I mean, the odds are astronomical, aren't they? Wow. That was supposed to be funny! Anyway, throughout observational history, Galileo first turned his telescope to the heavens in about 1610. He observed Neptune's movement. But remember, he was fascinated by all the things he was seeing, and this movement didn't make any sense to him, so he didn't follow up. But there were other professional astronomers that between the time it was discovered and Galileo had seen the movement, but they too never went back to question why. Few people were capable of making the necessary mathematical calculations in 1845. 2 men were capable, 2 men tried, and both men succeeded. Just remarkable. First time pure mathematics was used to discover a celestial body. And like I said a minute ago, it paved the way for all kinds of other kinds of observations and discoveries. So how do you know you don't know something if you don't know you don't know it? George Airy was convinced Uranus was it. There was nothing left in the solar system to discover. We just got to chart the known heavens, and that was his job. He didn't question anything. James Chalice worked with John Adams. He knew John, yet he questioned, can somebody do this? So he didn't take it very seriously. You have to keep asking why, what if, why not? Because that's human nature, to discover and explore. Those men didn't. It bounded their ability to understand what was going on. So did I just give you guys a book report? The Neptune File by Tom Standage, and an article in the July 2011 of Sky and Telescope. That's where I got most of my references, like 98%. So I want to thank you for listening to me ramble. How's the skies?
Not real good.
Looks pretty bad.
So there's no moon up tonight. Why? Where's the moon?
Already said.
Well, no. What's happening Sunday?
It's
Almost over the sun.
It's in the eastern sky right now in the early morning.
It's in the very early morning sky. Sunday, it's going to pass in front of the sun. That's how we're going to get that solar eclipse. That's going to happen late in the afternoon. So if you come back, you'll be able to see in the telescopes. So that's why there's no moon tonight. We sometimes can see the moon through the clouds. But are there any questions?
I have heard that
There's 3.
those 2 planets used to be swapped.
Neptune and Pluto.
Oh, is that what it is?
Those 2.
Okay.
And it's because of their orbits are so inclined and everything that there was a point where Pluto was inside of Neptune's orbit, but now they're back in normal, and Pluto's not even a planet anymore, so we can't count that.
You can't.
No, I know. I don't know why
Still
they
a planet in my heart.
It is not true. I mean, how did they grandfather that? I mean, just make one exception. Those morons. Anyway, I wasn't there. They didn't have me remind me. What else? There got to be more questions.
Mike, I've heard of Bode's law before, but I understood it better tonight just from your conversation. But does that apply to any of these other solar systems, or is that just coincidental?
It was very coincidental. It just happened to fall into the inner solar system. If you study planetary physics, there's things called resonances, and everything is in some kind of stable resonance, and our solar system seems to be in that right now. In a few, 100,000 years, it's going to be different, but it happens to fall into these nice mathematical progressions when things are in a natural resonance. It's a nature's balance type of thing. And that's all this was a coincidence. All these other solar systems that are being discovered around these other stars, there's nothing like that. There's no mathematical progression to say bing, bang, boom. But they believed it. I mean, it seemed to make sense to them back in the 1700s. Anything else?
I noticed the numbers for Jupiter and Saturn, the Bode's law seem to be kind of off. Is that expected, or?
They weren't off that much. Yeah, it wasn't spot on, but they were within the ballpark. Okay. Now, when you got to Uranus, I mean, it was way off. It was several radius of orbit units, whatever those are, way off, and that was too much. But you got to have a little bit of error because it's an approximation.
You were going to point to something over
Yeah.
on the wall.
Here's Aquarius, the constellation Aquarius. Here's Capricorn. So Neptune, when it was discovered, was basically in this position here somewhere. And the first week in November of last year, it was back in that spot. Oh, in this telescope, it's awesome. It's this little tiny dot that's this pretty blue color. I mean, it's incredibly blue. You can't miss it. Uranus is a hair more green. It's got a green tint to it. But it's a little disc, just like they saw, not a pinpoint of a star. And if we could put the telescope there tonight, and those guys are already set. Where are we at?
They're not even up yet.
Well, I think the sun right now is in this constellation because I saw Sagittarius the other morning about 4 a.m. and it was like over here. So I was up.
Do you know?
Yeah, next fall. These are fall constellations. So next fall, again, like Mike just said, you can go to the website. You can schedule this observatory for your own private viewing enjoyment. Just you, your family, some friends. If you're having a birthday, bring all your friends over here. You can't bring cake and ice cream, but you can start your party here and go back and open presents and impress your friends with everything that you know. But we're here for you guys to come as often as you want. And you got to come different times of the year because there's different stuff to see. In the fall, you'll be able to see Uranus and Neptune. Right now, we've got Mars, that red overhead, and we've got Venus over in the west, and we've got Saturn over here in the east at sunset.
So do you know exactly how planets get their colors?
I know, I can answer this, okay? But what I'm trying to do is figure out a way to answer. Again, planets aren't like stars. Stars are actually burning. Their energy of combustion is what we see. The planets are all reflected sunlight. They're reflecting sunlight back at us. So depending on the gases in their atmosphere is how they reflect the sunlight back at us. Saturn is a more golden color. Venus and Jupiter are white. And Uranus and Neptune are blue and a little off blue towards green. But it's because of their gases in the atmosphere and how they reflect the sunlight back at us, giving them their color. Okay?
All the ones beyond Mars are not terrestrial, they're just gaseous.
That's true. We have two kinds of planets. The inner solar system up through Mars and actually the asteroids are rocky bodies. Everything beyond are more gas giants, except Pluto. We'll find out what's happening at Pluto in about 5 years when a spacecraft goes flying by there. I can't wait. So it may be rocky. I suspect it's more like a comet than it is a gas giant. Because everything out there seems to be rocky, icy balls. So leftover building blocks of the solar system that get flung out there. Anything else?
Can you repeat the time for the Venus transit?
It starts the afternoon of June 5th, which is a Tuesday, I put in the newspaper article. I write for the Berthoud paper. I write for the Longmont paper. I write for Denver paper. I write for a lot of little communities between here and Broomfield. The little Thompson Observatory was going to open at 5 that night.
Well, probably 4 o'clock.
4 or 5. And again, the first contact is 6:10. You won't really start to see anything happening until about 6:30 or 7, when more of the planet starts eating a little bite out of the edge of the sun. And then by sunset or near sunset, it's going to be well into the disk of the sun.
And then any paper and Fort Collins?
No, I don't. My article is free, but you know how hard it is to get a free article in a newspaper? Very hard. I don't know. It's hard. I got into 4 papers because it's the same publisher that does 4. They do the Superior paper, the Lafayette paper, the Frederick paper, and another one kind of east of I-25. And it's the same editor, and I met him at the Lafayette Peach Festival. I walked up to this guy and said, "You want to run my article? It's free." So that's how I got in that paper. So you got to kind of meet the guys.
There's nothing between Berthoud and Fort Collins that you write for?
No.
Okay.
I don't get that far north. Anyway, I got that opportunity because I volunteer at the observatory, and about 12 or 13 years ago, somebody said, "Does anybody, of the volunteers, does anybody want to write a newspaper article?" I said, "Well, so I've been doing it for about 12 years now. So. Well, thank you.
Thanks, Mike. Well, unfortunately, it's totally cloudy and it's almost raining, I think, so we got some sprinkles tonight.
So one thing you need to do is go up and look at the telescope. I mean, that's kind of impressive, if that's possible.
You can just look at the 18-inch telescope, or we can take you up to the historical NASA Apollo telescope that we have on this side. It's almost ready to work. Probably after the summer, we'll have it operational. This was a 24-inch telescope that was built for the Apollo program in 1963 to figure out if the moon had a solid surface or a really soft, dusty surface. NASA didn't want to lose the astronauts 30 feet of dust. That would be a good calculation. So this telescope has been at Mount Wilson Observatory in Pasadena for 50 years. And it became available in 2004. We have been working to get it here, and in 2007 we picked it up. In 2009 we installed it, so we have been working on it ever since to make it. So I can bring you up there, show you, make it move for you, but it's not, we cannot look through it yet. So. And if people are interested, I can talk a little bit about constellations, proto-constellations or anything like that. So we can entertain you a little bit longer. The day what we should do is go up and see this telescope. My t-shirt is on. By the time you stretch your legs a little bit.